Yes! Hello! I get a lot of viewer suggestions, people telling me to do all sorts of different things. In today's video, we're going to go through a few of those suggestions and see if they actually work. Just kidding. What's up, everyone? Welcome to Lowered Expectations. Thanks for lowering your expectations and hanging out with me here. I do appreciate it. A huge shout out to Dave McLucky for being the best Chinese diesel heater YouTube creator out there. Of course, he does all sorts of other stuff, but I'm mostly interested in the diesel heater stuff. Go check him out. A big thanks to everyone who's been getting involved, whether that's subscribing to my channel, leaving likes on the videos, or getting involved in the comment section. All that stuff really helps. I do appreciate it, so thank you very much. Also, a big shout out to everyone who's used my affiliate link to purchase one of the heaters that is similar to mine. For those of you who don't know, I purchased this heater with my own money. VEVOR saw some of my videos and decided they would ask me if I wanted to work with them. I said yes, and as a result, we have an affiliate link. What that means is if you guys use that link in the description below to purchase one of these heaters, I get a small kickback that helps me out. Also, you guys get a discount code, which is VVS10 for $10 off, or VV promo for 5% off store-wide. If you guys are interested in any of that stuff, links, all that information in the description below, so go check that out. And now for the safety warning. I have been doing all sorts of experiments on my heater trying to burn waste motor oil, and I would suggest that you guys not do the same. Follow your manufacturer's recommendations, whether that be the fuel they tell you to burn, the way they tell you to install it, or the way they tell you to operate it. Doing what you see me do could cause injury, death, damage to property, or a complete loss of property, so just don't do what I do. Use your heater the way it was intended to be used. Do it. As suggested in the opening clip, this video is going to be about viewer suggestions. I'm not going to get around to all of them, and also I want to make it clear that I'm not picking on anybody, and I would have liked to make dedicated videos to each of these things, but I just don't have time. It would be years of videos, and I don't think they're interesting enough on their own. Again, no offense to those people who recommended these. There was lots of people who recommended each of these things, but basically what happened is I tried these tests, or tried these little things while I was doing other tests. And so, yeah, it's going to be a bit of a messy video. It's going to jump around a little bit. I'm going to do my best to try to edit it together so that it makes sense for you guys. But basically, there's going to be me jumping in and talking to you like this, and then clips that go all the way back to January 6th, I believe, and then kind of move ahead through time. Anyway, let's get into it with the very first viewer suggestion. In one of my very first videos, I told you guys that I removed the baffle to clean out the burn chamber, the area on the inlet, just where the air goes in. And I've had several viewer suggestions on advice on how to reattach it. And one of the ones that I keep getting, that I keep having to explain to people, is the magnet idea. I didn't have a dedicated clip to show you guys, but I had another clip where I was talking about getting carbon on the fan and the heater backfiring, and so I'm going to show you guys that clip right now to try to show you a little bit about how close the fan actually runs to the baffle. This diameter here fits right over the top of that. So close that if you make a bracket that's just a little bit too thick for here, it will actually rub on the fan itself. So runs really close. A few people have commented asking why I don't show the glow plug or the screen or the process of cleaning. And the reason why I don't is because they're never really bad. And also mentioned the hole there. Anyway, the hole is clear, as you guys can see. Pretty easy to tell as soon as you glance in there. And the plug, this is after it not running good at all, and it is clean. I'll pull the screen out and show you that as well. Here is my glow plug mesh. As you guys can see, even after the unit wasn't running very good, this isn't terribly wet or completely covered in soot. I wanted to point something out that some people seem to be confused about, and the mesh is only there for starting. Once the unit is started up, this has no effect on the operation of the unit whatsoever. This is only for starting. If you want to know how I know that, it's because if you I recommend that you never do this, but if you power your unit off without allowing the glow plug to kick in, this will be wet. And it's wet because the oil runs through this. This doesn't stay hot enough during operation for the oil to actually burn on it. So the oil runs through this into the burn chamber and then ignites. The only time this is hot is during startup and shutdown. As most of you will know, I don't have control over my air-fuel ratio as of yet, and because of this, a bunch of you have suggested that I use my air compressor to blow air into the inlet and make the corrections that are necessary. I have had lengthy discussions with a few people in the comment section, one of you being, sorry I forget your name, but one of you being somebody who worked on commercial waste oil heaters and is actually has a few videos and is actually building an extremely modified version of a Chinese diesel heater with a carburetor on it, sort of. That's the way I would describe it, using compressed air to actually draw in fuel and combust it with the compressed air. Air compressors are extremely inefficient. They use a huge amount of power and they have a huge amount of loss. A lot of those losses are just through heat. And so it's just not a very efficient process. You can do it two ways. You can have high volume, low pressure, or high pressure, low volume. With high volume, low pressure, that's basically the way the fan works. Fans are much better at doing high volume, low pressure than air compressors are. If you try to run an air compressor at high volume, low pressure, it's just going to run non-stop. It's going to wear your air compressor out and you're going to end up spending more money in electricity than you ever saved in fuel cost. To do high pressure, low volume is the way that you would want to go about doing this, but it would be extremely hard to control because of something that I've chatted with a bunch of you in the comments, and that is the extremely minuscule amount of fuel that these things burn. I'm going to try to get through this quickly and be as accurate as I can, but yeah, this is my third time trying to say this. So, at full heat, these things pump at 7 hertz, which means my pump pumps 0.22 milliliters per stroke. No, 0.022 milliliters per stroke, which means at full hertz, at 7 hertz, my pump will pump 9 milliliters per minute, which is about 2 teaspoons, for those of you who don't understand milliliters. So, why this is a problem is in order to make a change, this is at full speed, mind you, this is at full heat range, 7 hertz is basically what you run the pump at. The reason why this is a problem is if you want to make a change, you're making a change percentage-wise to 9 milliliters over a minute. So if I want to make a 5% change to 9, that is 0.45 milliliters per minute. So if you make even the smallest, tiniest change on these heaters with fuel input or air input, it makes a huge, huge difference, and the ability to control things so finely is extremely difficult. So while you can build a waste oil furnace that uses compressed air on high pressure, low volume, lots of people have done it, and that's the way most of them actually work. While you can do it this way, it's not a terribly practical way to go about doing it in one of these heaters. Now that I've talked for 5 minutes, let's actually see the clip of what happened. I've tested this a bunch of times and pretty much got the same result, but I'm just going to show you guys this one really bad clip, so here you go. Oh my God. overheated it. Can't leave well enough alone, Joel. So I wasn't watching the controller. I blew some air in here and it overheated that quickly. So that tells us that it needed more air. I'm gonna collect some of this stuff. Somebody was telling me that if it is, actually two people told me, if it is indeed sulfur, then it will melt at a fairly low temperature, so we'll hit it with the torch and see what happens. It doesn't look like anything that would be reactive. It's definitely not melting. Yeah, I don't see any reaction. Literally no one asked me about this, but I came up with this idea on my own and decided to try it, but not actually test it or keep track of the results in any way. The idea was to try to raise the temperature of the burn chamber by insulating it with thicker gaskets. But at the time, I didn't have a thermocouple on the outside of the burn chamber. Currently, I do have a thermocouple on the outside of the burn chamber that keeps track of the temperature where the oil goes in. But at the time, I didn't have this. So basically, I did the test along with other tests, and I had no way to track the data. So here's past Joel talking about a thing that he thinks might work. I was just thinking about the way that this heater works and the fact that the burn chamber has to be connected to the heat exchanger. The job of the heat exchanger is to get rid of heat. The job of the burner is to get hot. This area of the burner, just behind this baffle, has to get very hot to vaporize the fuel, even when it's running diesel. So ideally what you would want is the burn chamber insulated from the heat exchanger, because basically what you have here, the mounting surface for the burn chamber is basically a radiator that is getting rid of heat in this area of the burn chamber, and it's getting rid of that heat directly into the heat exchanger, which cools off this part. So we want a bunch of heat in this area, and we're keeping it cool. So if we could have a graphite gasket or something that insulated fairly well between these two surfaces, that could actually make a substantial difference in how well these burned waste oil. I was just responding to a comment. Somebody said that they thought that maybe the bracket that I made here was interfering with airflow. So I might try just gluing this in place and see what happens. I suspect that there's not enough airflow through here to actually, for that bracket rather, to cause any disturbance in the flow. Those are my thoughts, but I could be very wrong about that. All right, I am going to install this plate. I've got some epoxy on there. I'm a little too impatient to be using epoxy on something like this, but I'm gonna give it a go anyway and hope. That's it. And it's locked into place. Still got the little nubbins there. I guess I should probably plug that hole in the center too. We'll use some This is probably going to be the longest part of the video, and I've had this comment or suggestion from a number of people from the very first video that I posted until the very last video that I posted. And that is the way that I route my exhaust, all the bends in it, and the fact that I used the ventilation system. So I didn't document all of this terribly well. This was kind of happening while I was doing other tests. But here is a bunch of footage of me actually removing the exhaust off of the heater to test it. And yeah, let's just watch this footage and see what happens. All right, folks, it is acting kind of weird. Still making that noise. A few people have said that it's because I have sharp bends in my exhaust and that my exhaust isn't running straight down. So what I'm going to do to try to figure out if that has anything to do with it, I'm actually going to remove the exhaust altogether. So how stinky is this going to be? Do I have the remote in my pocket? Yes, so I can shut it down from outside if I need to. $2.16. Oh. Actually not that stinky. It's kind of starting to burn my eyes a bit, but 210. Maybe the exhaust does have something to do with it. It sounds like it's stabilized. I'll have to run it for a few minutes like this, so I'm going to open up the door. Okay. As soon as I put the pipe back on, it starts acting up. Interesting, very interesting. So, I'm not sure if the people who told me this knew something from testing or I don't know, but based on what I saw on the heater, I would not have guessed this. I didn't guess this. In fact, I commented to those people saying that I would probably try it, but I didn't think that it was going to work. What convinced me the most that it wasn't that was two things, actually. One is that the exhaust port, so when you look at it from the outside, that's actually substantially bigger than what it is on the inside. And the other thing is that on the lower settings, it still does that same thing. So it could be a frequency thing. My brain's starting to rush now. My brain's starting to go crazy trying to figure out why this would be. This is my new setup. I've got the heater sitting on the shelf with a hole in the bottom of the shelf. Gas tank, fuel tank rather, in the same place that it was. Diesel tank basically. I've moved the fuel pump. Oh, the fuel is shut off. Idiot. I'm probably going to have a few people upset at me for cutting this test short because I've had several people suggest that the ventilation system is either causing not enough flow or too much flow. Equal parts of each. But the reason why I stopped doing this test is because the heater wasn't working any better. I tried it with the exhaust completely off and it didn't want to start and run. And then I tried it with the straight pipe, and because the heater wasn't starting and running properly, it was dumping a huge amount of smoke into my garage, which is terribly unhealthy and not very safe either. So I made a U-bend in the pipe and ran it into the bottom of the duct, which causes absolutely no restriction and also doesn't cause, there's no pull. I'm gonna grab a piece of paper right now, put it by my vent, and show you guys. Yeah, let's just go over there. Don't do this at home, kids. Play safe. Fire can be dangerous, especially if you panic easily. I've got a rag here. I'm gonna light it on fire and make a bunch of smoke, and we'll see what happens with that smoke. As you can see, the smoke very gently goes up. That's pretty cool looking, isn't it? As you guys can see, the smoke very gently climbs up into my ventilation. There is not a lot of fast flow, but there is still flow. So that shows you guys that, yeah, neither of these concerns are valid. The smoke is being evacuated, but it's not being sucked out very aggressively. So there's not an excessive amount of airflow, but there is some airflow. That escalated quickly. Cut! I think it has more to do with the length of the exhaust, or the tuned shape of it, than those bends, but we'll find out. I could be wrong. The difference is, if I'm wrong, I get to make a video saying that I was wrong. Is it even going to start better with the curvy exhaust? Sure seems like it. I spoke too soon, but I wonder if there's just air in the system. Alright, so yeah, there's fuel in that line. I'm not sure what happened. We'll restart it. It lit immediately, and it's staying lit. Wow, impressive. Oh, it's gonna flame out. Curious. Crap. Shut itself off again. I'm getting pretty sick of this. So, maybe there's actually something wrong with my heater, or maybe it's some of the modifications that I've done to it. Even running on diesel, it doesn't want to start up without me choking off the intake. So there's not a problem with that, which just makes sense because I was burning diesel. So yeah, nothing there. I am going to remove this plate off the back here because, yeah, I don't know what else to check. Thanks for making it all the way to the end of the video. I do appreciate it. If you liked what you saw, remember to give it a thumbs up. And if you want to see more of this, remember to subscribe. I was going to add a few extra things to this video. I wanted to test the fuel pressure on the pump to see what it can actually build. I don't think it's very high. I have a gauge for it. I have some T's. I was ready to do it and then realized that the last test that I did on my heater needs to be checked out. I'm running out of time, and I would need to strip the heater down, clean it out, and then put it back together to do this test. And I just don't have time to do that right now. So that will be a future test. If you guys are interested in purchasing one of these heaters, once again, I do have an affiliate link in the description below. If you use that link, it helps me out as I get a small kickback. There is also a promo code VVS10 for $10 off, or VV promo for 5% off store-wide. In my next video, I'm going to be cutting open my burn chamber and taking a look inside. A big shout out to Hobby Channel Germany for giving me this idea. He actually made a video for me, and a whole bunch of you have seen his video and recommended that I go watch the video. Also, a big thanks to Shane. I'm sorry I forget your channel name and don't remember if you have your full name posted, but I will try to post that here. He cut his chamber open with a saw and showed that there was a mesh inside. So in the next video, we're going to cut mine open, take a look inside, continue on with the experiments. That is going to do it for this one. If you guys want to support me on Patreon, that is an option. There is a link in the description below for that as well. But yes, that is going to do it for this one. Thanks for watching, and I will see you next time.